And we should be live. 1 second. There we go. Okay. Nice. Can you hear me? Test. Maybe I'll music a bit lower. Perfect. Let's wait, and then we start. Okay. Can you see me? Okay. Bit lower, I think, like that. Should be live. Let me check. It's a bit slow. Let's see. Okay, we are live, right? Okay. So, first of all, today is Christmas Eve, and but we're here live coding Rust. I'm audible. Thank you so much. There we go. Perfect. So let's go here, and we can start. So before we start, let's go dev. Perfect. Should be okay. So this is the second part of the guessing game. We are trying to make a game following this book, the Rust programming language book. This will be a very long one. So we are just at the beginning, chapter 2. We made the first part where we basically have this simple Rust code, but still it's not simple if you are not used in the Rust syntax. Super fast recap. This is to import a library. This is the function main. Fn stands for function. This is basically a print function. This exclamation mark means that's a macro, and then we declare a variable. Usually the variables, can you make a playlist Rust for smart contracts? We are not there yet, probably at some point. First I want to make the basics of Rust. So by default all the variables in Rust are immutable. So if you type let guess, it's as when you say const guess. To make the variable mutable you have to say mute. So let mute, it's mutable. And we are declaring a string. And we also notice that what is really amazing in Rust is that you have this sort of embedded structure. When a variable has something called expected, we'll see something called error. And we are reading the line. And this ampersand is this because this is getting a reference to the variable guess. Now let's skip this part because we already did it, and now we should be testing the first part, just a fast test. I don't know if you can see here at the bottom. So I downloaded an extension, so if you want you can download it. It's called Rust Analyzer, this one. So Rust Analyzer makes something super cool that allows you to have this. I don't know if you can see it. This. So you can click this run and it runs the function. It's super cool. Check it out. Check here. I click run and it starts instead of typing cargo run. And here I can put any number I want, 1, 2, 3, and you guessed 1, 2, 3, and it's over. Amazing. Yeah, cargo run is the alternative. Yeah, I've done cargo run so far, and that's it. Perfect. So let's go back. Yeah, I also make this live streams because I made some small researches. Let's go now. Let's start the lesson number 4. So generating a secret number. Next, we need to generate a secret number, because for now we are basically generating a string, not a number. So let's see. We need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play, of course. We'll use a random number between 1 and 100, so the game isn't too difficult, okay. Rust doesn't yet include a random number functionality in its standard library. However, the Rust team does provide a rand create. Create, I think it's sort of package with said functionality. So we need to use a different create. If I click here, okay, creates.io. It's basically npm. Okay. So, using a crate to get more functionality. This is getting very interesting, so follow this part because I think this will be very interesting. A crate is a collection of Rust source code files. The project we have been building is a binary crate, which is an executable. We create a .exe file. The rand crate is a library crate, so a library. It's sort of like saying like a library, npm library, which contains code that is intended to be used in other programs and can't be executed on its own. So the goal of the library crate is not to be an executable, but to be something that is used by someone else code and create the executable. Nice. So Cargo's coordination of external crates is where Cargo really shines. Okay, let's see. Before we can write code that uses rand, we need to modify the cargo.toml file. The cargo.toml file, it's basically the package.json. We will probably add something here on the dependencies part. Open that file now and add the following line to the bottom beneath the dependencies section header that Cargo created for you. Be sure to specify rand exactly as we have here, with this version number, or the code examples in this tutorial may not work, so we want to use config file. No, it's Balamur. Usually I make examples for people who come from using Node.js, so it's like a package.json, or it's like requirements.txt if you use Python. Usually I make analogies more with the Node.js, but it's basically a file when you have the dependencies. It can be like the pom.xml file for Java, we can say. Finally. Okay, so let's copy this exactly line. So rand here stands for random. We are getting the random car crate. Hey, Epic Dash. In the cargo.toml file, everything that follows a header is part of the section. Okay. Is part of that section that continues until another section starts. In dependencies, you tell Cargo which external crates your project depends on and which version of those crates you require. In this case, we specify the rand crate with the semantic version 0.8.5, so we're using a specific version, but for what we need, I think even the 0.01 would work, because we're getting the random functionality. Cargo understands semantic versionage, which is basically using three different, this is style of using like number, sometimes called semver, which is a standard for adding versions. Okay, not bad. Okay, let's go here. Cargo considers these versions to have a public API compatible with version 0.8.5, and this specification ensures you will get the latest patch release that will still compile with the code in this chapter. Any version 0.9.0 or greater is not guaranteed to have the same API as what the following examples use. Okay, now without changing any of the code, let's build the project. So let's use cargo build here. So clear, can you see? Cargo build. Can you see here? It built the... Okay, we have a subscriber. Amazing. But I can't see this in the chat. Cool. Thank you. I think something is broken here. Okay. Type in the chat. And okay. So we built this one. Now, okay. You may see different version numbers. Okay. When you include an external dependency, Cargo fetches the latest versions of everything the dependency needs from the registry, which is a copy of data from crates.io. Yes, crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. It's exactly npm. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed round as a dependency, Cargo also grabbed other crates that run depends on the work, so it's like a chain of dependencies, of course. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. Okay. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Okay. If you open the src main.rs file, make a trivial change and then save it and build again. You'll only see 2 lines of input. Okay, so this here it's making just an example. Those lines show Cargo only updates the build with your tiny change. Okay, and it's not a change in the dependencies, so it's a change just in the code and not in the dependencies. Okay, now ensuring reproducible builds with the cargo.log file. By the way, at the end of the live stream, all the code will be available here at my Rust Crash Course repository. This one. If you want to leave a star, you will make me happy. Nice. Okay. Okay. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo.lock file. It's very similar to the package -lock.json. When you build your project in the future, Cargo will see that the cargo.log file exists and will use the version specified there rather than doing all the work of figuring out versions again. Okay. Okay. Updating a crate to get a new version. When you don't want to update a crate, here we are doing a bit of theory, but I think this is necessary. This is crucial because we are trying to understand how the dependencies work in the Rust. So this is, we are not going into the details of the program, but we're going into the details of how Rust is handling the dependencies. It's a really crucial part to understand. Okay, it might be a bit boring, but it is what it is. We are trying to learn the basics. I'm sorry. Now, okay. This is just an example. In yours, the 0.9.0 release, at this point you also notice a change in your cargo.log file. This is just an example, okay. Let's go here. Oh, okay. Generating a random number. Let's start using round to generate a random to guesses. So we will let Rust generate a random number. And generating random stuff might always be useful. Okay, I think it's just this line. Okay. So, round, thread, RNG, gen, range. Okay, the syntax it's a bit cryptic, but I don't know. I like the Rust syntax. So we need to make some changes here because we have basically these two lines. Let's see. So we are going line by line. So let's go on main.rs. So this is like guessing, generating the random number. So we have just two lines here. We let this secret number, which is defined in a constant variable, and here it doesn't like it. Okay, but it might be because I have to build. Maybe I skipped a part. But I did the build. Let's see. Let's see. It's complaining. Let's see. Secret number is, if I run it, we have an error. Okay, let's go back here. Yes. I have to. I forgot to add this because they didn't show the differences. Okay. So I have to import the random parts. Okay. So we saved some time here because yes. Yeah, because they didn't show the difference. Okay, let's try again. Okay, let's try again. Let's run, and we should see a random number, 81. Okay, if we do this again, I should terminate the task. Let's try again, 29. Okay, so we are generating random numbers, so we are getting there. Of course, in this case it's kind of easy because we are printing the secret number on the screen, but this is just for us because we are developing it now. And as you can see here, we have this secret number. This is the type of the number. We're using this function rand, and then we generate this range, and this is pretty self-explanatory. I don't know. It's a bit on the screen. Okay, here. Sorry. Okay. I think I can do this. Okay. Nice. Should be better now. Okay, nice. Okay, so this is already good for this lesson. Let's see if we can go a bit deeper. Okay, so first add the line. Okay. Okay, so I didn't read here, but okay. I want to read here fast to understand what's going on. So use rand RNG. Okay, two lines. The first line we call rand thread RNG function gives us the particular random number generator we are going to use. One that is local to the current thread. This one is defined by the range trait. Okay. The gen range method takes a range expression, an argument, and generates a random range expression as an argument. So I think we are also seeing how to define a range in Rust here, which is cool. I have to say that it's cool here. 1 ... equal 100. Starts. Okay, so this is the syntax for a range in Rust. Amazing. Perfect. Okay, the second line prints the secret number. It's useful for the game. Okay, we already done this one. Okay. Okay, now this part. What is this? This code does not compile. Oh, nice. Okay, so this is just an example, okay. Now that we have user input and a random number, we can compare them. That step is shown in listing 2.4. Note that this code won't compile just yet, as we will explain. So I don't know if I want to copy this part. So we have this random library, the ordering part, and this one. Okay. And we have this match keyword, a new keyword called match. Too small, too big, you win. Okay. This makes sense. I also like the syntax a lot. Okay, so first we had another use statement. Bring a type called std cmp ordering into scope for the standard library. The ordering type is another enum that has the variance less, greater, equal. Okay, so it's basically to make comparisons. Okay, then we add 5 new lines at the bottom that use the ordering type. The CMP method compares 2 values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess to secret number, then it returns a variant of the ordering enum we brought into scope. Okay, we use a match expression. Okay, a match expression is made up of arms. Okay, an arm consists of a pattern to match against and the code that should be run if the value given to match fits that arm's pattern. It's a sort of powerful switch for me, so it's like it's trying to match something. Patterns and the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. Wow. So match, random, I'm getting super excited with Rust. Let's walk through an example with the match expression we use here. Okay. Say that the user has guessed 50 and the randomly generated secret number is 38. Okay, so the user guesses 50. When the code compares 50 to 38, the CMP method will return ordering greater, because 50 is greater. The match expression gets the ordering greater and starts checking each arm's pattern. So the first, the value does not match, so the match basically has these arms that gets evaluated one by one. Nice. However, the code won't compile yet. Let's see, what's the problem here? Expected string found integer. Okay, so we're getting to that problem, that basically we are generating a random number, but then this is a string. Secret number, it was a string. No, secret number was an integer, but the comparison here, it was expecting a string, because we are getting a string in input. Okay. The core of the error states that are mismatched types. Rust has a strong static type system. However, it also has type inference, so it infers the type. When we wrote let mut guess string, Rust was able to infer that guess should be a string. The secret number is a number type. Okay. So how do we solve this? With a cast. Okay. Rust cannot compare a string and a number type, but it's good that it's giving an error here, because here the program is small, but think if this was more complicated code. So we want to convert the string the program reads as input into a real number type. Okay, so I think it's this trim parts. Okay. The line is let guess, so the guess now it's a number that gets something in input and it parses it to a number. Okay. The only thing is that here we have a U38, but the other one it was I32, and here we have a I32. So this is the only thing that is not clear to me. Okay. Now, let's guess. Please type a number. Okay. Parse method on string. Okay, here there is some theory of comparing the two things. So let's see. I want to okay, let's copy the code now. So we need these are the library to import. So okay, then we have match 1 after the println. No, I think this is this is here. Okay. Okay, here we see the error of the secret. Hey Julia, hi. And we need to add this part, which is this one. So after the read line and expect, so we can remove this. This was the old guess part. Of course, it has to be done before. Today will not be a 12 hours live stream. No worries. Okay, why is not liking? Okay, let's see what the issue here. No, I think this is no, this has to be after we read. Okay. Okay, the only thing that is not clear here is that we define a variable called guess string, and then here we define a variable, constant variable called guess again, which is the trim of the guess variable. Okay, I don't know if this works. This does work. Yeah, let mute guess, let guess. Okay. Okay, and now let's try to run the program and let's see how it works. We are not close yet, but I think that I will end the live stream after this one. Let's see. Let's try to run it. Run. Please input your guess. My guess is 50. The secret number is 25. Too big. And it terminates. Okay, let's try again. Run. If I type 90. Too big, right? Let's try with guessing a smaller number, for example 11. Too small. Okay. And let's try to cheat. Let's type the number. Okay, so it generates 29. I input 29. You win. Okay, that was easy. Okay. Nice. Okay, and now allowing multiple guesses with looping. I think I'll stop here for today. Handling invalid input. the name of the extension to the repo. The name of the extension to the repo. No. Yes, the name of the extension. The name of the extension. Yes, the extension name. Okay. Rust Analyzer. You mean this one? Okay. Rust Analyzer. Yes. So let's stop. Let's stop for today, and we'll end up finish this on the 31st of December. So git. It's different. Let's see if we get more people. Git, so add git commit -m. This is random generator, and then we push. Maybe we can add this in the readme. What do you think? We don't have a readme file here. Probably we should. But I thought we had a random... We have this, but we don't have a readme.md. Let's see. Let's see. Because it's in projects. Okay, so let's do this. VS Code extension Rust Analyzer. Okay, I think maybe there is a link. I don't know if we can. Switch to the pre-release, disable, copy. Let's see if I can. Is this a URL? Okay, I'll leave a link in the repository. Okay. Like this, only for you. Remember to leave a star. Nice, 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 nice. Perfect. Done. So, let me make a recap of what we did today. This is the second part of programming a guessing game. So, today we worked with the random generator. And to do that, we can't use the default library into Rust, but we had to use something called create, which is basically a package. So to do this, we need to add this dependency in the cargo.toml file here, cargo.toml file, and here we are adding exactly this version of this rand create package. And then to generate a random number, we can use this command. The syntax it's a bit cryptic, but after I think you get used, it's super easy. This is something called range, which is very clean. Let me make this a bit bigger. Okay, and then what did we do? The problem here it was that we saw the match. Let's say structure, which is it's very cool because it's a sort of a switch, but it tries to match this pattern. So this, for example, this is perfect here. Sometimes it's less, sometimes it's greater, sometimes it's smaller, and sometimes it's equal. So it's great to handle all the possible patterns. I don't know if there is like a default one. It seems like a switch on steroids, but here it's very, very clean. And then we had a problem because we tried to compare a string to a number, and the good thing is that Rust here is throwing an error because yeah, it could try to make an automatic cast, but this usually leads to problems. So it's better to just throw an error here, and then you as a developer are forced to make these two things to be of the same type at compile time. Okay, it's great. And yes, that's it. So we build these parts, we put this into this number, and yes, now we have basically this is still a dumb game, but we are getting there, because we are generating a random number. Okay, we are printing it, but just as a debug feature. Then we let the user to guess the number, and then we say if the number was too big, too small, or if the person guessed the number correctly. The only problem is that now the user has just one chance, and even if we tell them that if the number was bigger or smaller, it makes no sense, because the users doesn't have another opportunity to try guessing the right number. So in the next episode we will probably finish this part, allowing multiple guesses while looping. I see already here this loop keyword. I almost wanted to do this, but no. I have to resist. I have to try to keep them short. So let's go and I want to give some impressions. So my impression is that the more I use the Rust, the more I'm falling in love with this programming language. I'm very happy to learning this in public, so I can share my thoughts with you. And for now, what I really love is that I like the dependencies file. Simple, I need to get used, but I like it. I love the match constructor. When you have you have to you can match, hence the name, different patterns, and also that Rust is forcing us to find one of those patterns. Also, I like the VS Code extension. And that's it. The only thing is that we didn't have time to complete this part, but I'm not in a hurry. I want to take it easy. I also like the book. It's very clean, and it's trying to explain line by line what's going on. So that's it. These are my impressions are are very, very good about Rust. This will, in 2023, I want to dedicate more time, and if I start liking it a lot, I can also create a dedicated video, some shorts, but I'm still learning. We are still at episode 4. I don't want to make these episodes too long, and that's it. So many bookmarks. No, you didn't see the rest. Would you recommend learning to code just by reading docs? It depends. If you do this in public, I think it is the best solution. Otherwise, you can also watch some very good videos. But I don't want to watch videos together. It doesn't make sense for me. So this is why I decided to make this learning in public, because I'm reading the docs and then I am explaining. This is a format that I really like. Thank you, Madara. Thank you, Madara. We are about to close the stream, so I just want to tell you Merry Christmas if you celebrate it, or pass a good Sunday with all your beloved ones. And we are done. If you like this series, remember to leave a like, share the video, because the more I get traction of this series and the more I dedicate more time in creating content about Rust. I'm really enjoying it. Thank you so much, Adara. Merry Christmas. Thank you. So that's it. Very, very, very simple. We are still doing simple examples, but I'm really liking it. Thank you so much also for starting the repository. For hours, for what? Nice. We are done. So thank you so much, everyone. Thank you so much for jumping in these live streams. I'll always appreciate it. And yes, see you next Saturday, 3 p.m. CT. Feel free to leave a comment, leave a feedback about this series, because I'm still learning, but I'm really enjoying doing this together. Bye bye, everyone.